Have you ever thought about traveling to outer space? Where would you go? What do you even know out there? We live on Earth and it's part of the Milky Way Galaxy. But what is the Milky Way Galaxy and why is it called Milky Way? That's what we're about to know now. Studying the Milky Way used to be notoriously difficult. Astronomers sometimes compare the effort to attempting to describe the size and structure of a forest while being lost in the middle of it. From our position on Earth, we simply lack an overview. But two groundbreaking space telescopes launched since the 1990s have helped usher in the golden age of Milky Way research. Major strides have been made, especially since the 2013 launch of the European Space Agency's ESA Gaia mission. Visible in the night sky, where light pollution permits, as a mesmerizing glowing band of stars and dust, the Milky Way has fascinated humans for millennia. Attempts to chart the galaxy date back to ancient Greece. But it wasn't until the 1920s that astronomers realized that the Milky Way is only one of many galaxies populating the universe. Up until then, most believed the Milky Way and the universe were one. American astronomer Edwin Hubble, the one in whose honor the famous space telescope was named, cracked the mystery when he managed to determine the distance of the Andromeda Nebula. This fuzzy object, known since the 18th century, was originally thought to be just a different kind of star in the Milky Way. But Hubble's observations proved that Andromeda was much too far away and was, in fact, a galaxy on its own, just like the Milky Way. Since then, astronomers have learned that Andromeda will one day bring about the end of our galaxy as we know it when the two collide some 4 to 5 billion years from now. Since Hubble's time, astronomers have figured out that there are billions of galaxies in the universe of various shapes and sizes. And they've made major strides in understanding the Milky Way. Our Milky Way galaxy is about 100,000 light-years across and is a spiral galaxy in structure. Improving telescope technology enabled astronomers to distinguish the basic shape and structure of some of the closest galaxies before they knew they were looking at galaxies. But reconstructing the shape and structure of our own galactic home was slow and tedious. The process involved building catalogs of stars, charting their positions in the sky and determining how far from Earth they are. Dutch astronomer Jan Oort, sometimes dubbed the master of the galactic system, was the first to realize that the Milky Way isn't motionless but rotates, and he calculated speeds at which stars at various distances orbit around the galactic center. It also was Oort who determined the position of our Sun in the vast galaxy. The Oort cloud, a repository of trillions of comets far from the Sun, was named after him. Gradually, a complex picture emerged of a spiral galaxy that appears quite ordinary. At the center of the Milky Way sits a supermassive black hole called Sagittarius A*. With a mass equal to that of 4 million suns, the black hole, discovered in 1974, can be observed in the sky with radio telescopes close to the constellation Sagittarius. Everything else in the galaxy revolves around this powerful gateway to nothingness. In its immediate surroundings is a tightly packed region of dust, gas and stars called the Galactic Bulge. In the case of the Milky Way, this bulge is peanut-shaped, measuring 10,000 light-years across, according to ESA. It harbors 10 billion stars, out of the Milky Way's total of about 200 billion, mostly old red giants, which formed in the early stages of the galaxy's evolution. Beyond the bulge extends the galactic disk. This feature is 100,000 light-years across and 1,000 light-years thick, and it's home to the majority of the galaxy's stars, including our Sun. Stars in the disk are dispersed in clouds of stellar dust and gas. When we look up to the sky at night, it's the edge-on view of this disk extending toward the galactic center that takes our breath away. Stars in the disk orbit around the galactic center, forming swirling streams that appear to emanate like arms from the galactic bulge. Research into the mechanisms that drive the creation of the spiral arms is still in its infancy, but the latest studies suggest that these arms form and disperse within relatively short periods of time of up to 100 million years, out of the galaxy's 13 billion years of evolution. Inside those arms, stars, dust and gas are more tightly packed than in the more loosely filled areas of the galactic disk, and this increased density triggers more intense star formation. As a result, stars in the galactic disk tend to be much younger than those in the bulge. Spiral arms are like traffic jams in that the gas and stars crowd together and move more slowly in the arms. As material passes through the dense spiral arms, it is compressed and this triggers more star formation. Denisot Camargo, of the Federal University of Rio Grande do Sul in Brazil, said in a statement. The Milky Way currently has 4 spiral arms. There are 2 main arms, Perseus and Scutum Centaurus, and the Sagittarius and Local arm, which are less pronounced. Scientists still discuss the exact position and shape of these arms using Gaia data. The disk is not flat but warped. As it rotates, it precesses like a wobbling spinning top, according to ESA. This wobble, essentially a giant ripple, circles the galactic center much more slowly than the stars in the disk, completing a full rotation in about 600 to 700 million years. For comparison, it takes our Sun 230 million years to complete one lap. Astronomers think this ripple may be a result of a past collision with another galaxy. Sprinkled around the disk and the bulge are globular clusters, collections of ancient stars, as well as approximately 50 dwarf galaxies that are either orbiting or colliding with the larger Milky Way.